Good morning, MEFB 2132013 Manufacturing Processes class. Welcome back to our next chapter, Computer Numerical Control Systems. So what is numerical control? Yeah. So we're looking at how industries operate. Some of them use numerical control. Numerical control is the system that we have in the manufacturing processes lab. Yeah. So where we actually key in numbers, we do the settings of feed by just turning the knob. It's more of a manual type of operation, and we save it. We can save the data. Yeah. So then we have something. So it is the control of the machine tools operations by means of numerical data. Data are stored on paper, magnetic tape, computer disk, or direct computer information. Then we have something called computer numerical control, CNC. Computer numerical control is an automated system. So we have one in the BF block here. We have a computer numerical control milling machine. So how does a computer control milling machine works, or lathe machine works? Okay, so it's the same operation, just as how you perform milling in the lab, in the manufacturing lab, but now it is automated, meaning that you have a mainframe. Okay, you have a mainframe that you can key in codes. Okay, so you have a mainframe that you can key in codes. Okay, so the mainframe is connected to your computer. So if this is it, okay, so you work on G codes and N codes. Yeah, so for example, I don't recall what are the G codes, but for example, if G01 is to tell your tool to move left, G02 is to make your tool move right. So you're going to key in based on the dimensions here. So this is your object. So you want your tool to move in the x-axis by 5. So if you want it to move right, so it's going to be G02 x5 y0 z0, and you find your tool come here. Then you want it to move in the z direction. So if you want it to move in the z direction by 7 units, so it will be x0, x direction is move up, so G04 x0 y0 z7. So your tool will move from here to here. So you define the part of the tool until you finish the whole cycle and come back to the origin. Okay, once you finish the whole cycle and come back to the origin, you can simulate this. So when you hit the start button, it will actually show you how your tool is going to move, and if wrongly keyed in a value, it will indicate an error so that you can correct it, and then you can replay it again. And once you replay it, if everything is perfect, you hit the start button, and the program or the instructions will be sent to your milling machine. The milling machine will machine it according to the program being given to it. Okay, so computer numerical control system is a control system that is built in a computer that supports the machine tool operations. The basic function of a CNC system is automatic, precise motion and positioning of the tool and workpiece. So DNC or direct numerical control is the same as CNC, except that now by using one program, we can interconnect 5 different mainframes, and or from one mainframe we can interconnect to 5 different machines. So 5 different machines can take instructions from one mainframe, and therefore simultaneously 5 processes will take place, machining as simultaneously. Yeah. So DNC also may stand for distributed numerical control. This is more recent definition of DNC. Hence also a central computer is used, but it serves several CNC machines having onboard microprocessors. What are the advantages of CNC and NC? The non-productive time is less. So when you use CNC, when you use manual, what you do? For example, if you take lathe, yeah, you need to go and clamp your object, clamp your cutting tool, you start it up, and then sometimes, if you remember, during your manufacturing processes lab, while you're machining, you find that your workpiece is vibrating a lot, meaning that it's not been attached well. So you unclamp it and reclamp it again, and then you start your machining process. So this is all setup time, which is a lot of time taken just to set it up. And then if you have a problem in between, and when you do it manually, you need to measure, right? To measure, to make sure your dimensions is correct. So you have to stop the machine halfway, you put your vernier caliper machine dimension right, okay, then you continue. So it's a lot of unnecessary time wasted, okay, as compared to when you do it by CNC. The non-productive time is the time that you stop the machine to do measurement, you stop the machine to unclamp it because it's vibrating, and reclamp it again, okay. All this is the non-productive time. The non-productive time is less, and chip time or the machining time is increased. The number of jigs and fixtures is reduced because tool has better access to workpiece because of the program. So you do not need to keep changing if you need to do a different design, you did not have to change the jig and fixture or the mold. The program will be able to select the mold and put it in place, and you can do the machining. Yeah. Because of the program, complicated parts can be easily produced. So any complicated shapes can be easily produced, and obviously due to the automation, time required for machine setup cycle and cycle time is reduced. So machine setup is the time that you clamp your object, unclamp it, blah blah blah, and the cycle time is the time taken to produce one product. Okay, so what is the cycle time? The time taken to produce one product. Okay, we find that the CNC machines are more flexible than special purpose machines. It's more reliable because you get better quality products because the dimensions have already been defined. Therefore, you have less rejects. Machine modification may be performed just by changing the program. So by changing the program, you can change the design of the product, and inspection costs are reduced. What are the disadvantages? High cost of the machine tool. The machine becomes non-productive if the control system breaks down, and control systems are expensive. Okay, so control, in this case, what is the heart of the machining? The control system. Yeah, the control system is the one that controls the sequence of the programs. So if the control system crashes, the machine becomes non-productive, and for you to actually replace the control systems are very, very expensive. So even though your machine is in excellent condition, but the problem lies in the control system, your machine still cannot function because the control system stores all the data or sequence of movements. So even if your machine is in perfect condition, it cannot function. And a high cost of the control system because of its sophistication. Types of controllers. Okay, so control system, there's so many types of controllers. Yeah, we have the sequential control, uses electromechanical devices to control the machine motion. We have a PLC, programmable logic control, which is a solid state device with a central processing unit with input and output devices. We have an automatic adaptive control, identifies continuously online performance of operation, compares it with the expected value, and automatically adjusts one or more parameters to improve the process. We have numerical control, uses pre-recorded written symbolic instructions. And if you find that, let me pick just two controllers here. Depending on its level of sophistication, the performance of the control system varies. So if you take number 2, yeah, programmable logic control. Programmable logic control involves input, process it, and output. Okay, you have input, process, output. So if you input garbage, it's going to process the garbage, and it'll give you an output of garbage. It will not rectify the problem. So at the end of the day, you need to redo the whole program again because does not have a feedback mechanism, meaning that it is an open loop control. Okay, open loop control does not give us a feedback. Then secondly, we have closed loop control. Closed loop control, an example would be automatic adaptive control. So automatic adaptive control is special because it can give you feedback. So it practices the closed loop mechanism. So when you input, it will process the input, and if it finds that there is an error in the input, it will rectify and adjust to the closest value, and then it will prompt the user if the value is right. Then when the user says yes, okay, I made a mistake, and it can accept the value that is suggested by the mainframe, or the user can go and correct the value. Once corrected, it will recalculate the whole program again, and then it will project the expected or the correct expected output. So obviously automatic adaptive control is more sophisticated, because it can rectify a mistake and it can correct it. Okay, so unlike PLCs, where it will give you, if you key in the wrong value, it will give you a wrong output. Okay, that's it from this chapter. Thank you very much.